right, so this guy is approximately now, you can think of it just as 5 to the x grows a lot faster than 3 to the x. So our answer is going to be 0. Five gets bigger much faster than 3. 5 to the x gets bigger much faster than 3 to the x. So this guy will always be divided by more, so it approaches 0. If that bothers you, you can pull out the 2/3. You got 3 to the x over 5 to the x. Okay, at this point, you could make a little table. You think, okay, 3 to the x, 5 to the x. So as x gets large, let's see, first let's start with a 1, you have a 3 and a 5, 2, you have a 9 and a 25. You can see this guy's getting much bigger faster. Just with a couple values. Let's say a 10, 3 to the 10th versus 5 to the 10th. You might want to get out your calculator and figure out what that is. And you can see that this thing will be 0. Technically, you might say this is equals 2/3 times 0, which is 0, because we popped the 2/3 out. Another way to look at this, still, write it as 3/5 to the x. Now, you may remember from pre-calculus or similar class that, say, here's what 2 to the x looks like, and the opposite there, 2 to the negative x. This 2 to the negative x, this is 1/2 to the x, because this is 1 over 2 to the x. Okay. So 2 is bigger than 1. If the base is bigger than 1, then the graph goes that way, like that. Here, 3/5 is less than 1, so the graph will be similar to 1/2 to the x. Not exactly the same, but it will be similar. 3/5 to the x. You can see that the limit as x approaches infinity, as x gets large, y gets small, close to 0. So again, another way to think about this, but it's perfectly fine. I'm probably doing overkill here with the explanation. It's perfectly fine to just say, okay, look, 5 to the x grows much faster than 3 to the x. That's equal to 0.